This video will be a bit different than all my other videos thus far. In this video, it'll be more of a follow along to make this cheat sheet with me, okay? So in the past, as I've helped people with the units about infinite sequences and series, specifically the part about testing infinite series for convergence or divergence, people get very intimidated by that. Okay, so they don't know which test to use and the conditions for each test, or they don't remember all the conditions or the results of each test, how to interpret them and all that, okay? So this cheat sheet will be kind of a one-stop shop for referencing all the tests and their conditions and how to interpret their results to conclude convergence or divergence and stuff like that, okay? So many students found this to be helpful as they use this cheat sheet to practice on a lot of problems. And of course, as they got more familiar, as they practiced more problems, they start to use the cheat sheet less, okay? And I think just writing this cheat sheet in itself is a good exercise to review all the tests and kind of reinforce what you learned already, okay? And if you don't remember, it should be a good reminder, or relearning even, okay? I don't know what state you're at, okay? But let's begin. Okay, so we are going to first start with two special types of series. By the way, this is targeted for students who are taking Math 2B at UCI. Okay, specifically for those people, but this cheat sheet could be used for other people too, like people taking calculus in a different school or something like that, okay? The reason I say that it's more targeted for UCI Math 2B students is because I took the class there, and I'm very familiar with what they probably will ask on the final exam and all that. Okay, so anyway, let's begin. So we're going to first start with two special series that you should know. The first one is the geometric series. Okay, so I would do something like this, geometric series, as a title, kind of. And then how does it look? We have summation as n goes from 0 to infinity, some r to the n. Okay? We know for geometric series, the absolute value of r has to be less than 1 in order for it to converge. I'm going to shorthand convergent and divergent. Converge like this, and divergent like this, okay? We know geometric series diverges when absolute value of r is greater than or equal to 1. It's inclusive of 1 because simple case, 1 to the n, you're summing an infinite amount of 1, so of course it will be an infinite sum. Okay, so this is the condition for convergence for a geometric series. We also know, excuse me, for a convergent geometric series, what the sum is. The sum, I remember as the first term over 1 minus the common ratio. I will write it in words because this is how I remember it. First term over 1 minus common ratio. The reason I remember as first term is because it's only the first, what the value of n is starting off as. Sometimes it's starting off at 0, so in that case, common ratio to the 0 power should be 1, so it'll be 1 over 1 minus common ratio, you might remember as that. But sometimes it starts from like 1, sometimes it starts from 5, you don't know. So it's in general, it's the first term, so if it's, for example, starting off at 5, then it'll be r to the 5th power would be the first term, okay? So that would go up there. That's how I remember it. The next special series that you learn is the p-series. Okay, and how does that look? It's the summation, n goes from, let's start from 1 to infinity, 1 over n to some p power. Okay, we know the p-series converges when p is greater than 1. When p is less than or equal to 1, it diverges. Okay, we can easily remember this by, for example, if p is equal to 1, that's the harmonic series. We know that 1 over n, the harmonic series, diverges. 1 over n squared, we know that converges. So you can kind of remember it like that too. Okay, so at least in UCI Math 2B, these are the two important special series that you learn. Okay, in addition to, for example, the Taylor series of e to x, that stuff. But I'm assuming that's a separate topic, okay? I'll say that. Okay, so those are two special series that you should remember. Now let's move on to the tests that you learn, okay? The first one was the test for divergence. Let me use a black pen. And what does that say? Okay, if limit n goes to infinity of some sequence a sub n, if that does not exist or does not equal to 0, okay, then summation of a sub n, okay, you can write the limits even. I'm just going to shorthand it like this, diverges. Okay, remember, when you're testing for series, we quickly eyeball if a good way to quickly test if it's possibly convergent is we do the test for divergence. If this limit does not equal to 0, we immediately know that it diverges. If it equals 0, then we have to do some other tests. Okay? That's what the test for divergence says. We also learned the integral test. Okay? This one has conditions. This is important. Okay? Because you might have to show all the conditions to be true in order to get the full amount of points. Okay? So if we have some sequence a sub n again, okay, we define the continuous version f sub n. So I just do it as n for convenience also. I know a lot of textbooks do f of x as the continuous version, but it doesn't matter, it's just a variable name, okay? So conditions. Okay, there's 3 conditions. F of n is continuous, okay? F of n is positive, and f of n is decreasing. Okay, those are important 3 conditions. Continuous, positive, decreasing. Continuity should be easy to show. Positive should be relatively easy to show also. F of n is decreasing, you could just take the derivative to show that it's decreasing. If the derivative is negative within some region, for example, if it's from some finite number all the way to infinity is decreasing, it doesn't have to start decreasing right away, but as long as it decreases as it goes to infinity, it's fine, okay? Hopefully that makes sense, okay? But these are important conditions to use the integral test, okay? Then if integral from 1 to infinity of f of n dn converges, then the summation version converges, okay? Similarly, if integral 1 to infinity f of n dn diverges, then the summation version diverges. Okay? That's what the integral test says. Okay? Let's go next. Let me squeeze in at the bottom of this paper the comparison test. What does that say? This is quite intuitive. If summation of b sub n converges and a sub n is less than or equal to b sub n, then summation of a sub n also converges, okay? Similarly, if summation of b of n diverges and a sub n is greater than or equal to b sub n, then a sub n, the series, summation of a sub n, diverges as well. So this is saying something smaller than something we know that's convergent must also converge. Something bigger than something that we know is divergent must also diverge. Okay? That's what the comparison test says. Okay, we move on to the limit comparison test. That's a little bit different. Let me do it up here. what does that say? If we take the limit n goes to infinity of two sequences, a sub n over b sub n, we call the result C. If C is finite and positive, then either both series converge or both diverge, okay? Series being the summation of a sub n and the summation of a sub b, okay? That's what the limit comparison test says. Okay, let's move on. We have the alternating series test. Okay, this one has conditions again. One condition. So alternating series looks like this. I'll have some alternating sign. Looks something like this, okay? So we have conditions. One condition, if b sub n is decreasing, okay? That's the big condition. And if limit n goes to infinity, b sub n is equal to 0, then the series, then the alternating series, I should say, the alternating series converges, okay? The tricky part here is showing that it's decreasing, because this limit is usually easy to find. By the way, if it's not equal to 0, if it's equal to, for example, 1, then you can't use the alternating series test. Only if it equals 0, then we can use the alternating series test conclusion, okay? If the limit is not equal to 0, it doesn't tell us anything, okay? Last two, we have the ratio and root test. They're very similar. Let me do the ratio test first. Trying to squeeze it all on one sheet. Okay, if we have limit as n goes to infinity of a sub n plus 1 over a sub n, we call that the limit equal to L. If L is less than 1, the series, so I'll just write that sum, converges, okay? If it equals to 1, then it's inconclusive. If L is greater than 1, then the series diverges, okay? And then finally we have the root test. Okay, that's limit n goes to infinity of the nth root of the absolute value of an, okay? Again, if we call that L, it's the exact same conditions as the ratio test. Let's write it one more time though. If L less than 1, the series converges. If L equals 1, it's inconclusive. And if L greater than 1, the series diverges, okay? And those are all the tests that you learn, at least in Math 2B. Okay, so hopefully this cheat sheet will be useful to reference as you're practicing problems for testing infinite series for conversions. Okay, you can just look at one sheet instead of flipping through the textbook or your notes. For all the tests, this is a kind of one-stop shop for everything, okay? And then hopefully the exercise, I don't know if I said this earlier, this exercise of just writing this cheat sheet was a good review or reinforcement of what you have learned in the course, okay? So hopefully this is a good exercise and hopefully you followed along to write this cheat sheet. If not, I would highly recommend you do it, okay? It's just very useful to have this cheat sheet to reference as you practice problems, and then hopefully you notice that as you practice more and more problems, you use this cheat sheet less and less, okay? So please give this video a like if you found it helpful, or even if you just for some reason came back to this video to show your support after you wrote this cheat sheet and found it to be helpful as you practice problems. Thank you in advance if you are just coming back to like this video. Also, please subscribe to the channel to see kind of more videos like this instead of me solving problems, just me giving you tips to study for like math exams and all that.